Hey guys, I'm going to explain the molarity quiz just so that you have some feedback as to maybe if you missed a couple, why you missed those. The average score was 82%, which is a B minus, so that's really good. So most of these questions you guys did just fine on, but again, I just want to make sure that you have explanation so that if you did miss something, now you know what the correct answer is, and we'll go from there. So really quickly, number one, it's asking about mass percent. So mass percent equation is percentage equals the grams of your solute over either grams of solution or milliliters or liters. It just kind of depends on what's given to you. But the key word there is solution. And I tried to give you a hint on this because sometimes in a word problem like this, your solute and your solvent are not added together already to give you your solution. Okay, so if it were to say something that's in solution, that's fine. But in this case, it's telling me that I have 15.5 grams of my solute, which is my calcium hydroxide, and I'm dissolving that in 100 grams of water. Okay, well, 100 grams of water is not my solution. You don't get a solution until you actually add the solute to your solvent. So in this case, you have 115.5 is how many grams of solution you have. So when you do the math on this, you take the grams of your solute, 15.5, and divide it by 115.5. And then you can multiply that by 100, and that's going to give you that 13.4%. If you did 15.5 divided by 100, that's why you would have gotten the 15.5%, but that's incorrect because you did not put the solute with the solvent. So also on your quizzes and tests, I'll try and give you a little hint on that just because of all this online learning. And so that was just what I meant by make sure to calculate the solution first. So that's why you had to add those up before you actually did any of the division or the multiplication on that one. So 100 plus 100 or 15.5 gives you 115.5. That should have been your bottom number for that one. Okay. Number two is a molarity equation. So this is just plugging your numbers into your equation. So your molarity equals moles over liters. Well, in this case, it's asking us what the liters are. You're solving for volume. So your equation is going to end up looking like 12, which is your molarity, equals 0.6 over x. So when you do the math on that, you end up dividing 0.6 by 12. When you rearrange that to solve for that bottom number, you get 0.6 divided by 12. And when you do that, you get 0.05 liters, which is where that number comes from. So moles over liters, but you were solving for liters, you had molarity. So 0.6 divided by 12 gives you 0.05. Number three, also asking for molarity, but notice it gave you grams and milliliters, which most of the time grams and milliliters can be acceptable, but not when it comes to molarity. Molarity, it has to be moles and it has to be liters. So I have to know my molar mass of potassium nitrate. I can't use 32 in my molarity equation because I need moles of that. So I need to divide 32 by its molar mass. So if you add that up, you get 101.1. So when I divide 32 by 101.1, I get 0.3 moles. So that's my top number. And then I'm going to convert milliliters to liters just by moving my decimal over 3 times to the left. So I get 0.4. So you're going to end up dividing 0.3, which is your moles of KNO3, divided by 0.4, which is your liters. And when you do that, you get 0.75, which just rounds to 0.8 for molarity. So just keep in mind that moles and liters are absolutely necessary for your molarity equation. If you're not in moles and liters, put yourself in moles and liters. Okay, for the next one, number 4, this is a concentration question. You have an initial molarity and you're solving for a final molarity. You have an initial volume and a final volume. So the concentration equation is M1 V1, molarity 1 times volume 1 equals molarity 2, M2 times V2, volume 2. So M1, V1 equals M2, V2. Just plug your numbers in. So you have your initial molarity, which is 0.5. You have your initial volume, which is 340 milliliters. Milliliters is totally acceptable in terms of volume, so you don't have to convert anything right here. So you have 0.5 times 340 equals, it's asking me to solve for M2. And notice that add is in all caps because I'm not saying that my final volume is 560. I'm adding that to 340. So my final volume is not 560, it's 900 because you need to add your initial volume and I'm adding 560 to that. So you should have 340 times 0.5 equals, I don't know M2, that's what I'm solving for, times 900. Okay, and when, again, you rearrange your equation, 0.5 times 340, that left-hand side is 170, and then you would divide over 900. So 170 divided by 900 gives you 0.19 molar. Okay, for this next equation, same thing, it's molarity, moles and liters. So notice that I'm actually solving for grams. So this is going to be a two-step problem. I was given my volume and I was given my molarity. So I actually need to solve for moles first. So when you plug in your numbers, 2, M equals, so 2 equals X, I don't know what my moles are, divided by 0.25, again, because you're in molarity, so you have to have this in liters. So when you do 2 equals X over 0.25, you solve for X and you get 0.5 moles. Now, that is in moles, that is not grams. When you solve for that top number in molarity, you're solving for moles, but this specific problem asked me to take it one step further and convert from moles to grams. So 0.5 is technically maybe why some of these people got this one wrong, because 0.5 is part of your answer, but then you have to take that 0.5 and you need to convert that to grams. So you need to add up the molar mass of barium sulfate. So when you do that, you get 233.4 grams. So then you end up multiplying. 0.5 is my moles times my molar mass, 233.4, and that's where this 116.5 comes from. Okay, for this next one, this is a percent equation again. So you have zinc and copper zinc alloy. That's what brass is. So it's asking if you have a 35-gram pendant that only contains 1.7 grams of zinc, then what's the percentage? So this is grams of solute, which in this case is just my zinc, over grams of solution, technically, which is my alloy, brass, my alloy right here, is 35. So this one, you do not have to add these together. It's telling you my whole pendant, okay, is made of brass, is 35 grams. So in this case, you're just going to divide 1.7, that's your solute, by 35, there's your solution, and then you're going to multiply that times 100, and that's where the 4.9% comes from. If you answered 4.6, it's because you added 1.7 to 35. And in this case, you don't have to do that because when it gives you the pendant, it's telling you already that's the whole solution. So you're just going to divide 1.7 by 35, multiply by 100. That's your 4.9%. Okay, number 7 for the next one. Also a percentage problem. This was by far the most missed question. So you are trying to figure out how many grams it takes of your solute to make 200 milliliters of a 15% solution. So again, you have your percent concentration equals grams of your solute over grams of your solution. So in this case, it gave me my percent, so 15% equals, I don't know my grams of my solute, that's what it's asking me to find. And then I do know my, this is milliliters, so this is a gram to milliliter percent concentration, so mass volume. So I have a setup of 15% equals X over 200. Now, because this is a percent, and when you're going to do math with a percent, you have to take it out of percent form. So this is not 15%, it's actually 0.15. So 0.15 equals X over 200. When you solve for that, you get 30, which I think most people did that just fine. You know it was 30 grams. However, when you need to make a total 200 solution, if I measured out 200 milliliters of water, and so picture this in a graduated cylinder. I have 200 milliliters of water, and then I add another 30 grams of salt on top of that. No longer is my final volume going to be 200. Okay, when you add your solute into your 200 milliliters, that's not going to give you a total volume of 200 milliliters. So when you make solutions, you don't put your final amount until after you put in your solute. So for example, in this case, I'm going to add 30 grams to only 170 milliliters of water because that is going to then get me up to my 200 milliliters. So when you make a solution, if I wanted to make 200 milliliters as myself as a teacher, I would probably take 100 milliliters and I would put my solute in, whatever solution I was making, I would put my solute in. Then from there, I would see how much that raised me, and then I would add enough water to get me to my final volume. So when you're making a solution, rule of thumb, do not go ahead and add all of the water that you need before you even add any solute, because if you do that, you're going to end up with more than your total, which again is going to start messing with your concentration. So that's not something that you want to do. So that one was, most people got the 30 grams correct. You solved for it correctly. But again, just pay attention to, you need your total to be 200, okay, which is why this is the answer for that one. Okay, next one. If I dilute 250 mils of a 0.1 molar solution, I have a final volume. So this is just a dilution equation. So again, M1V1 equals M2V2. I know that I have an initial volume and I have an initial concentration, which is 0.1 molarity. And it's telling me that I'm diluting it to 750 mils. So there's my V2. So I have my initial volume, I have my final volume, I have my initial molarity, and I have to solve for my final molarity. So again, this is just plugging in your equation. Most people did this beautifully. You would have 0.1 times 250 equals X times 750. And when you divide, when you multiply 0.1 times 250, it's 25. And then you would divide over 750. And that's where the 0.033 molar comes from. Also, this makes sense because if you'll notice, you didn't have a very concentrated solution to begin with. It was only 0.1 molar. And if you're diluting it, this is only going to go down. Okay, so when you are looking at your answer too, make sure that the answer that you're putting down makes sense. Okay, in order for your molarity to go up, you would have to add solute. You wouldn't add any more water, because when you add water, think about Kool-Aid. If you have really, really strong Kool-Aid and it's a little too much, you add more water in there to kind of dilute that out. So when you dilute something, your molarity goes down. So automatically on this one, you could have eliminated both 3 and 30, because it would have made no sense for your molarity, which is your concentration, to go up when you're diluting it. So again, use your contextual clues along with this when you have multiple choice answers in front of you. And if you can eliminate some, then it kind of narrows down your chances of getting it correctly, okay? All right, number 9, you have molarity again, and it's given you grams, and it's given you milliliters. Again, grams and milliliters is not what you need for molarity. So you're going to take 325.4. You're going to divide it by the molar mass of aluminum chloride, which is 133.34. So divide that out. That's going to give you your number of moles. So I got 2.44 moles. And then again, take your milliliters. You're going to convert that to liters, which is 0.5. So you're going to end up dividing 2.44 moles of aluminum chloride over 0.5 liters. And when you do that, you get 4.88 molar. So again, just knowing your equations and knowing the units that you have to be in will be very helpful, especially when you do this on your test. Okay, and the very last question, you have 286.7 grams of PBO. You need 2.5 molar. So given this number of grams, how many liters are you actually going to be able to make? So again, this is just a molarity equation. So you have 2.5 molar, okay, lead 2 oxide here. So you have grams. So again, molarity, nothing to do with grams. It needs moles. So you're going to take this 286.7, get that into moles. So you're going to divide by the molar mass of lead 2 oxide, which in this case is 223.2. So when you divide that out, you get 1.28 moles. So there's your moles. You have your molarity. So your equation should look like 2.5 equals 1.28 moles of lead 2 oxide divided by X. Okay, you're solving for liters here. So when you solve for X, you're going to end up dividing 1.28 moles by 2.5 molar, and you get 0.514 liters. Okay, so this case, again, it's just making sure that you're getting into the units that you need to get into, and it's making sure that you plug them in and then doing the right math to solve for them. So those are the answers to numbers 1 through 10. And again, I just wanted to kind of review that with you so that you knew which ones you missed and why you missed those. This is going to be on your test on Friday. So if you have any other questions about molarity or solutions or anything like that, I will be on Canvas the rest of this week. So don't hesitate to jump on and ask me questions about this stuff. Okay, thanks for listening, and I hope this helped.